Hey, so this is recording number 2 today. I am actually going to try to do this at a regular pace and see how long it takes. Hold on. I don't know why I started the thing before I poured myself a beverage. Kind of a bad habit that I have. I have decaf coffee and tea. Oh my goodness. And yeah, I don't really care about the 30 seconds there. But yeah, all right. It's going to be casual. Let's see if I can do it. So, Linux and its microcomputer predecessors pre-1996. I value accuracy, so if you find any mistakes, I built something for you to correct me. You will also find the script I'm reading. This is a general talk, so here are some of the players for a 20th century journey if you haven't met them. Let's ramp up the time machine. We all use Linux, even if we don't know it. Whenever you see a machine reboot at a grocery store, it's like, oh, hey, there's that penguin again. Linux has arguably become the most ubiquitous operating system. How did that happen? The story usually given is an undergraduate posted about his hobby project, and a bunch of people helped out. Wait, a college kid with a hobby project started a computer revolution by posting? That's absurd. What about these other things that existed? They're only the Unix-ish ones. Oberon by Pascal's Nicholas Wirth is from 1987, and there were other ones. I found in the back of magazines and long-forgotten Usenet posts. They didn't even make the deck. But these did. Here's various commercial efforts. Some of these are complete systems, others are kernels. The lines are between the first and last release. The point is Linus wasn't shouting out from the wilderness. There was a vibrant Unix on the PC ecosystem that predated him substantially, an industry which hasn't had lasting impact. Products such as Xenix and Coherent were hot stuff at one time, but now are the works of Ozymandias. Look on the timeline, ye mighty, and despair. I can only find one... No. That's because this guy, Genghis Khan, the Unix war. I could only find one commercial Unix without hardware attached to it still around. Xinuos UnixWare 7 Definitive 2018, which last release was actually in 2017. And that's it. It's deader than dial-up. But Mr. Mackenzie, there's more to the story. What about the BSD lawsuits? Okay, well, what about them? BSD has a history stretching back to 1976. The two names for our story are husband and wife team Bill and Lynn Jolitz. Why didn't that win the Unix war? Well, this is usually given, but I'm not persuaded. BSD is much older, and in an interview with Bill Jolitz in 1994, he says he started working on 36 BSD when 36 came out in 1986, even though only something called Net 1 and Net 2 were released in that interim. He claimed to have started. That's right. He claims to have... No, I think that's shorter. He says he started. He says he's... Yeah, that's a fewer... All right. Okay, let's assume that there was a 2-year hold on BSD. Then we should go over to, say, Usenet and see a fair amount of silence during this time. But in fact, we don't. This is just over 2 days. It was lively and vibrant. There is no evidence of any chilling effect. The highlighted post is an update on the lawsuit, amidst a bunch of articles talking about progress and bugs. I mapped out the velocity of 386 BSD Usenet articles and tried to see if there's any change correlated with the court case's activities, and although I'm not a data scientist, they looked completely unrelated. Lastly, there's a number of articles across Usenet with titles like Linux or 386 BSD, where people compare them, although many included minutiae such as specific hardware, none talked about the lawsuit. So I have to reject the hypothesis that BSD was held back because there's no contemporaneous evidence. Tell me how wrong I am, go to the URL and denounce me at your leisure. Regardless, Linux has become a few orders of magnitude more prevalent than BSD and eclipsed all other Unixes. Why is that? I present two possibilities, the great man theory and a social history. The second is harder. Let's try the first. It looks really easy. It says some glorious thing happened, but you can't do it because you don't have the right genes. Unfortunately, that isn't useful unless you enjoy sulking about things you consider flops. But you're all rock stars, right? So let's go to second. Using the power of syllogisms, mere mortals did this. We are mere mortals. Therefore, we can do this, but only if we know how. The first is a much shorter speech, a Carlyle-style hero worship about how great men should rule and others should revere them. I could have made a gushing mystical biopic. However, we have a much harder job. And to do that, we must have defendable and falsifiable hypotheses. But first, here's some more jargon. Perhaps Linux was the second act of the personal computer revolution, personal software on personal hardware. If the center will not hold, things fall apart. Mere anarchy is loose upon the world. We might as well make it productive and get nice software out of it. Maybe a free Unix needed a pool of hackers to build it on cheap computers with a robust communication network and avoid a bunch of bad actors taking advantage of their generosity. Maybe. There's also the maybe nots. That falsifiable thing I talked about. Unix was thought to be really complicated. Actually, it was seen as quite elegant and simple. The Unix source license was 200K in the 80s, so of course it was complicated and magical, but that was marketing. Even 386 BSD, 20 years into Unix, was done by the Jolitzes, a husband and wife team, just two people. Community-based programs were thought impossible. There's an organization called Share who came up with the Share operating system in the late 50s, which was community developed. This was eventually structured closer to a buyer's cooperative. To see how it worked around the birth of Unix, let's go to Computer World, 1968. During the past 4 months, Share has been working with IBM to define changes needed by users. When the company responded, 12 out of the 13 requests had been turned down. Well, look what happens when you ignore the users. Oh yeah, Share was based out of LA, so LA Pride, I guess. Speaking of things that happened before I was born, this is ancient history. Although Unix started in 1969, the first paper was 1974. I've extracted 4 principles from it that will be useful for our journey. Leverage, don't invent. Doing beats planning. Needs, not desires. Use early, use often. Although each one may have its flaws, together they form a cohesion, even a synergy, if you will. Unix was designed for classic computers that died out, called mini-computers. They were about an order of magnitude or two, cheaper than the mainframes and also less capable. Well, at first, people wanted to solve their mainframe tasks on cheaper machines, because that might have been all they had access to. Roughly every decade, or a new lower-priced computer class forms, based on a new programming platform, network, and interface, resulting in new usage and the establishment of a new industry. That's called Bell's Law, and it's from 1972. As mini-computers came on the market and became more powerful, Unix was there to leverage them to service people's needs. The new machines provide a new context for new software. These needs are only meant as examples. The point is the velocity of computer progress went faster than people's needs. You could say it looks like computer performance increased as a square of the cost, and that transistors per chip doubled about every 18 months. Those are called Grosh's and Moore's law, and together it meant that the industry eventually ate itself through a multi-decade-long digestion. However, when new things come in, the people who get there early don't get there easy. It's okay though, some of us are crazy and prefer it. AT&T was under a lot of legal restrictions, and because of that, Unix was initially distributed as if it came out of the back of an unmarked white van. The chart on the right was part of the standard presentation deck for early Unix saying you're on your own. Think of the adventure, think of the excitement. But who are you catering to with such a message? What will be the behavior of those people who take the project? Where will the behavior of those people take? It's not about welcoming everybody doing anything. With any of these efforts, you have to ask yourself who you're bringing to the door and what kind of behavior you're expecting. That's what separates a library from a soccer field. For instance, Linus in October 1991. You also need to be something of a hacker to set it up. So for those hoping for an alternative to Minix 386, please ignore me. It is currently meant for hackers interested in operating systems and 386 with access to Minix. Maintaining focus is about intentionally, not incidentally, but actually intentionally choosing what to ignore. You have to be a clear signal amongst our noisy world. Because you had to know what you were doing, Unix was initially introduced through engineering and technical people, and not through the conventional decision makers. But it worked, and by the 80s, Unix was mainstream. As both the consumers and the producers of Unix multiplied, suppliers differentiated themselves by succumbing to the trappings of the usual competitive markets. You can call this enclosing the commons, trying to take ownership of groups and commonly held things by setting up barriers so you don't lose them, thus locking them in and growing your base by trying to look special. Unix had infected everything from workstations to mainframes. Unisys, one of the mainframe makers, had an article in September 1987 issue of Computer World predicting a tripling of Unix sales over a single year. The problem with the infighting goes back to the chart with various blobs about computer classes. The threat is almost always coming from below. In this case, it was Microsoft and microcomputers, and not Nixdorf's Cynix on an NS32000 versus clicks on an Intergraph Interpro. In 1985, Microsoft argued that Xenix Unix, which had an install base of 100,000, would be the multi-user version of DOS. In 1987, they said they didn't see it competing with their plans for OS/2, which at the time was seen as a successor to Windows 1.0. I know things changed, specifically that December with the introduction of Windows 2.0 and later with Windows for Workgroup and NT. That was the real threat. Anyway, in 1985, Xenix required 12 360K floppies, which was seen as bonkers. Have 12 360K floppies here. So you'd have to put each one of these into the machines manually. It'd be crazy. Insert floppy number 7. Where was I going? In case you're even younger than me, a 32 gigabyte micro SD card is about 93,000 of these. That's 190 meters stacked end to end. That's like a 2.5 minute walk. All that storage is now in a thumbnail and costs as much as a taco on the west side. Anyway, software distribution used to suck. Speaking of Microsoft, that punch tape is now how they distributed BASIC for the Altair in the 1970s. It took about 20 minutes to load, and of course it wasn't then stored on disk because the Altair didn't have one. Just keep the computer on if you want to use the software. It's also worth noting lower right. That's called a type-in program. Software used to be distributed like this as multiple pages of hexadecimal. I'm serious. No, I'm serious. Look, this is MLX format. They published listings like this every month. For years, you typed it in. There was no electronic reader. You can see some basic code from the first page, and it's not pretty either. The QR code is this game running on an emulator in your browser. You can just scan and tap it on your phone. No typing required. You don't want to give it a trial? Leave it up for a few seconds. You can only use the software that you have access to. And for many people, that meant retail or mail order channels. You could also order a copy of floppy from a friend. The bottom two methods had consumer overhead. For dial-up, you usually had to pay expensive phone bill, and for the internet, you probably didn't have it. This means that most people were only exposed to the top 3 groups, and thus was difficult for smaller developers, and especially non-commercial ones, to get their software to the masses. Quoting Marketing High Technologies by Bill Davidow in 1986, "It's not a product without a distribution channel, or in Linux's case, a distribution. The technology may have the potential to address the needs of many, but without specialist distributors, to put in the hands of those customers, it will not succeed. Products are sold through distribution, not to distribution." I need to jump forward to the why Linux question here for a bit while this diagram is up. Linux had high accessibility of the installed media. Not only were there websites that you would mail your CDs for $1, but you could find them at coffee shops, libraries, and attached to magazines at the grocery store. Filling up a CD with a Linux distro and heavily cribbing a bunch of well-written how-tos was cheap content for a magazine producer who just wanted to get an issue out. But let's go back to the problems. Depending on the distribution channel, updates had different logistic complexity, especially when considering updates from outsiders. For instance, if you wanted to update the retail Lotus 123 and have your changes appear on the shelf at Circuit City, you'd probably have to do it yourself and get arrested. It would have been fun, though. Once there were online networks which could provide the storage and communication necessary to unlock multiplayer online mode for the software development game, a new form of writing software was created. Yaki Benkler made up a term commons-based peer production in 2001 and wrote a book on it called The Wealth of Networks in 2006. Let's go to Linux, 1991. I've enjoyed doing it, and someone might enjoy looking at it and even modifying it for their own needs. It's still small enough to understand, use, and modify, and I'm looking forward to any comments you might have. I'd like to hear from you so I can add your software to the system. GNU has a Rooseveltian list, 4 software freedoms to define free software. There's got to be something more than this. Transition. That's it. There's no transition. Control B, transition. But for our purposes, we're going to talk about horizontaling software development, or what I call adoptive, because it's not just licenses, organization plus license. Essentially, how easy is it for modifications to become integrated and in the same distribution channel, other people to become a distributor or to share your product. You need not only a decent legal structure, but software organizational structure that affords this, and an open shop that permits anyone to come in. Eric Gruen, I wouldn't say touched upon this, spoke to this in a seminal work, The Cathedral and the Bazaar. There is the Cathedral model, which is tall, in which source code is available, but development is restricted to an exclusive group. Contrast this with the Bazaar model, which is flat, in which code is developed over the internet in view of the public. The vertical lines here, from permissive to restrictive, is a general continuum. Public domain is seen as too permissive in the eyes of GNU, because you can license or re-privatize things. I've also read that copyleft and GPL are different from each, but I never went to law school. If you zoom in and you'll see non-computer things. I'll go over a few. Bottom right is facts. People ought to be really hesitant to modify facts and their public domain. Above that, you have most religions. Anyone can preach the good word and start a congregation, but at least in principle, the texts are sacred and inviolable. The texts are sacred. That's all you got to say. As we go up, we get jokes, recipes, human language, and at the top is folklore, which changed readily. As you move to the left of public domain, you get Wikipedia, which anyone can edit. On the restrictive adoptive side is social media. Anybody can contribute, but the platforms retain a bunch of rights. Classic commercial software is down on the hesitant and restrictive camp. The pink stuff is all Linux related. Minix is down here next to freeware and GCC in the hesitant category, below the pool labeled Unix is. Except for social media and Wikipedia, all of this is early 1990s, not 2024 accurate. Speaking of the past, let's go to the introduction of Minix. In 1986, commons-based peer production wasn't feasible. People didn't have the internet in their pocket like you do. Because of the prohibitive logistics around software distribution updates, especially customer-initiated, Minix was a cathedral. Also, it's worth noting it was a product of Prentice Hall, who wanted to sell textbooks and instructional material for Andrew Tannenbaum. So here's the Tannenbaum. So here's the relevant part from the announcement. It's not public domain. However, the publisher does not object to people making copies for friends. This is SneakerNet. If you want to sell it, which is the two categories above SneakerNet, retail or mail order, you need permission. In the book, you will find a postcard that you can use to order the software. That's your mail order again. And he says he doesn't want to copy a bunch of floppies, as in do SneakerNet, and then price it $80, which is really cheap. Commercial PC Unix generally started at $1,000 without the source. Now, I also mentioned Minix was adjacent to GCC, so what's up with that? GNU was also a cathedral. Here's an example from an early GNU Bulletin, 1987. We can see it listing out different distribution channels as they solicited funds to pay programmers to write more software like a software engineering firm might. A software engineering firm. Just do period. They played a second role as a provider of copyleft and eventually software under the GPL, and that came out a few years later. Every bulletin had a growing list of software by others that you could order basically at cost. As far as this goes, there's precedents. Here's one from 1976 trying to be a repository for, at that time, public domain software from smaller producers such as Code Publish and, say, Dr. Dobbs Journal. Some assembly programs ran over 40 pages long, and that you, of course, were expected to type in yourself. So people were looking for a more reasonable solution that didn't cost as much, but not all the pieces were there yet. All of these things required labor, coordination, and resources, and how you chose to instrument those made some things more possible than others. Ideas are bizarre even when their implementations are cathedrals. For instance, there were many graphical desktop computers, even though each one was a proprietary restrictive project. The superstructure of desktop computers operated in the adoptive space. Pretend we have a concept of a free operating system. We may not get all the parts right the first time, but the Platonic ideal exists. Well, kind of. It's as much a contemporaneous invention as anything else, as a pale true thought suspended in our life stream. We can go back to Vannevar Bush's Memex article, as we may think, in The Atlantic from 1945, to see the spirit of what we now call many things, as quoted over here on the left. Unlike products, Platonic ideals are collective projects owned by nobody. They are permissive and adoptive, and not static abstractions divorced from human influence. They are ideas manifested from context. The map is not the territory, and our industry, we are tasked with creating both through pure thought stuff. What a responsibility. We better organize. This is about the complexities of building software and not about electing people. You may have heard that commercial software began with Bill Gates' open letter to computer hobbyists in 1976, where he announced SneakerNet distribution of Altair Basic because he didn't get paid for each of the copies. That's not really where commercial software began. In the mid-50s, software was in-house coupled with hardware, or contract-based, as you can see in the 1959 ad for a programmer from punch card data processing. But the version of commercial software that had already built stuff you purchased copies of for a computer you already owned had existed since at least 1960. That had already built stuff. No, really, this is another falsifiable thing I want to go over. Bruce Parent's chapter in Open Sources, Stephen Levy's and Hackers, and Hacky Sack. They allude to this Garden of Eden in a past from which all have fallen, but where all software is once free. Really? Well, no. Here in 1966, claiming commercial software was a $100 million industry, and then 1969, 11 companies worth at least $100 million each got together to fight off the not-for-profit efforts. These manufacturers bundled software to lock in their customers like Microsoft did with Internet Explorer. It was as free as Windows was on your laptop. People were trying to DRM and patent software back in the 1960s. But maybe there was some idyllic Valhalla in the bubble known as MIT Artificial Intelligence Lab, but the real world was up to the same tricks as they are now. Anyway, debundling happened in 1968 and 69, vendor by vendor, and Unix arose from the primordial soup and is one of the oldest non-mainframe software that is still recognizable today. I say recognizable because the family tree looks like a European dynasty. This Unix timeline history chart covers a few years in the late 80s. If you were to zoom in, you'd see Minix, MIT Trix, SunOS, the Mach microkernel, Xenix, from the House of Free Software, AT&T, or the Kingdom of Microsoft. I'm still not a lawyer, but this is really complicated. Not only did the source and binary have different terms, but sometimes only certain organizations had access to them. For instance, if you're an educational institution with a pre-existing AT&T license, that you had access to BHD. So a version might have multiple parents, each with a different term sheet. It's a legal Habsburg. That's why a few slides ago, there's a puddle labeled Unixes. Even the Unix term itself is a confusing mess. Raise your hand if you think it's still copyrighted by AT&T. No. Over 30 years ago, AT&T sold the copyright to Novell, who then donated it to the Open Group, which is now a standards organization. Some Linuxes have gone through this process, so Linux is now Unix. Really, you're just finding this out right now. This stuff is absurd. We need something with clean documented history, a clear license, and easy answer to all of these problems. So Linux and effectively all modern open source projects have this solved. All development is open, and the history is well archived, and OSI-approved licenses solve the family tree problems. This structure that's now ubiquitous is one of Linux's main contributions. Also, let's talk about the internal politics of building software. In the abstract penguin slide, we cover the outside aspirational curve, where things take decades and opinions are strong in many. Things like paradigmatic ways of doing open source software developments took 20 years because the dominant to become dominant because of longevity. So become is right next to because, and that makes it confusing. To dominate. Because the longevity and applicability of the more abstract solutions is also on the same time frame as the implementations. But within that exists lower-level Maslowian motivations, and keeping things there make them more actionable. Let's say my network card isn't sending out packets. We can say that this bug is known, agreed upon, and demonstrable. So although it may not be easy, the labor path is traversable. Now a new network comes out. A new network card. Just drop the NE2000. I want to do that. I need it to work on Linux. This is a need. I could demonstrate and come to an agreement on what that would look like. Now pretend I wanted to do something and it wasn't designed to do. That's harder to demonstrate and agree upon. To get it actionable, I need to pull the desire into the lower curve so that a development cycle can encompass it. It's worth noting the Tannenbaum-Torvalds debate of 92 to illustrate this. Tannenbaum chastised Torvalds' approach because it wasn't a microkernel and Linux was exclusive to 386. Really, Linux was in these lower curves and Tannenbaum was trying to pull it up to higher curves where things move far slower. GNU-Hurd was a microkernel approach. Stallman claimed in the early 2000s that's why it was taking so long and wasn't very stable. The point is that the higher level curves are unlikely to succeed except as superstructures of the lower level functions, in the same way that our asymmetric approach to Platonic ideals happens in the back of incrementally more appropriate implementations, which widen snake a line from the 1950s IBM Share organization to GitHub. Through the process of clarifying the aspirations, they get... What am I doing here? Through the process of clarifying the aspirations, they get moved to concrete because they become material needs and bug problems. The clarity of the present stands in both the triumph and the wreckage of the past. You don't need to know the history of a spoken language or any other system in order to use it effectively, but it doesn't hurt. If you understand the price of everything, you'll know the value of most. I found an article and an advertisement from May 1990. Sun says they have a cheap $6,700 computer. Here's a PC at about 1/10 the cost, which is fine, if you can do the same things. Historically, that answer had been no, but referring back to the chart with needs and computing classes, this dynamic is likely to change soon. The 386 has many technical features, which made it more appropriate for Unix-style operating systems. And I decided to drop the next thing. But that's not only the kind of price there is. There's also the price of time. This is a conceptual, not quantitative graph. Essentially, Windows is the easiest to get up and running and going. But let's say you want to do something like batch convert a bunch of files or sort the contents, pick a field, extract the values, do some operation on them. These things get hard fast in Windows. Early on, 386 BSD and its cousins were a pain to set up, but they had networking before Linux. It was a more sophisticated project. However, there were fewer people working on it who tended to be more experienced, so they were busy and expensive. Linux was mostly students, which are famously cheap. It was also heavily hobbyist-oriented, which usually meant the systems were more hackable. While the other Unixes, they presumed you had something important to do. The more difficult and time-consuming it is for a customer to use an information system, the less likely they will be to use an information system. That's Calvin Moore's 1959. As the complexity of the problems became more intractable, the approachability of the lower levels and internals of the system became increasingly important because people tend to use the most convenient method in the least exacting mode available and stop as soon as minimally acceptable results are found. That's the principle of least effort. Hackers tend to build worlds where everything is possible, but nothing of interest is easy. Alan Perlis called this Turing tar pit in 1982. Pulling yourself out of the Turing tar pit from a capable to a usable system requires some engine to push it forward. Our wordy commons-based peer production model from before can also be seen as prosumer, a producer and a consumer put together. It's often used for social media where you are consuming other consumers' productions. Here, our engine is problem solution into integration, which keeps us in the bugs needs development cycle. With a bizarre method of development, the change reflects back quickly, which means that new users can have fewer problems with their different hardware. So other people with, say, my Netro card, it would just work. But where do you find the people to do that? Well, you build armies, of course. Large networks are important. Their utility can scale with the size of the network. The number of combinatorial subgroup participants from these larger collections grow more rapidly than the original utility of the groups that joined. That's Reed's law. For example, my friend and I start using Linux. I have a network card that doesn't work. I can now join this subgroup of people, becoming a we that needs this card to work. This only becomes an engine if you have the right people to complete the cycle we talked about. A network card that doesn't work. It only becomes an engine. Needs this card to work. The lowest level here are enthusiast developers and bug fixers, followed by the curious and hobbyists, and then the business needs and people like power plants and airports that can't have things fail. Arguably, one of the failings of the early BSDs is that they were too lopsided on the higher steps and thus couldn't get the virtuous cycle moving with enough velocity. Analyze the email addresses of about 2.5 million Usenet posts over a 2-year period, and you could see that there were almost always more commercial emails for BSD and more educational ones for Linux. So even though their general trend was ascending the staircase, Linux had more torque from the bottom groups. I call this a Linuxist revolutionary theory. The hacker vanguard forms a coalition with a personal computer proletariat, and a business-oriented bourgeoisie becomes interested, and finally the prohibitively assiduous aristocracy is able to use it. There is one last type of price, and that is of experts. Whether it's your own or you're fronting some cash, it's expensive. You could roughly assign a utility function as the capabilities divided by the effort required. Sometimes both capabilities and efforts increase over time. Blender, for instance, is highly capable software, but also takes a lot of expertise to use effectively. Many mobile and web applications, on the other hand, actually remove power user features over time and make the product require less effort while also making it less capable. Still, other software, APIs and frameworks, can have Fred Brooks' second system smell. They have a new version that's far more difficult to use and leads to inferior results, thus being an inversion of the graph and decreasing the utility of the product. Let's talk about the multiple arrows. In order to get a larger user base, you need a diverse... Oh, shit. Let's talk about the multiple arrows. when I have like a piece of paper in front of me and this thing, that kind of shit won't happen. Linux was able to achieve this by outsourcing the actual packaging of the OS/3 distributions. This is another insight of the bizarre software model. Since the entire structure is more flat and the structural organization barriers are mostly removed, as markets naturally subdivide and form, they can be quickly and readily addressed. Because we're doing social history, and because I dropped something, I'll use critical theorist Marcuse's idea of deradicalization. The dominant structures say markets subsume the novel. However, because in bazaars people can self-organize, they beat it to the punch and move faster than the market force, which is why open source decoupled soft structures are more dynamic and swift-footed than commercial approaches. Here's a chart from Innovator's Dilemma. describing different strategies that can be taken as technology gets better. You can generally either push upmarket to higher end consumers, which are the top two steps of the stairs, or you can stay with your existing customers, which might be the lower steps. However, because of the horizontal development of Linux and the existence of distributions run by multiple organizations, it was able to do multiple strategies at once, not only these, but any other ones that have been left out of the graph. A few slides ago, we saw how Linux was a horizontalist, bizarre approach to software internally. Let's look at the implications of this externally. This chart is from Andy Grove's 1995 text, Only the Paranoid Survive, describing how the industry moved from one-stop shop verticals to a horizontal structure. If we put this into an aspirational space, this can be viewed as part of the same decoupling superstructure as what the mainframes were doing in the late 1960s. The premise of this transition was a book called The Coming Computer Industry Shakedown by Stephen McClellan in 1984. Quoting, as software gains ascendancy, a new world will arise to characterize the activities of the industry. The key words will no longer be customization, specialization, and market niche. The new world will be integration. Systems integration will be the most sophisticated and difficult task computer companies will have to undertake. That quote being 40 years old gives us the privilege of seeing what happened. Essentially, 4 strategies were developed to tackle this problem. The first is to impose on the vertical by claiming you're the standard. But in practice, only one player can do that, so OS2 died. Apple took a different route by being its own vertical, and Linux had to push the wheel out of the tar pit and needed enough people to do it. Luckily, timing was on their side. When the internet was mostly accessed at universities, September annually brought in a flood of new people that had to be coached. However, as residential internet grew, the old guard termed 1993 as the eternal September, the beginning of the mainstreaming of internet access. For this to happen, cheap ISPs and web servers needed to exist quickly to support users. It's important to note that Linux was prima facie hobbyist and personal use oriented at this time. Linux Journal has articles in 1994 about it as a web server and running ISPs. However, 1994 texts such as Linux Getting Started, Unleashing the Workstation in Your PC, or Plug and Play Linux from 1993 went a lower 2 steps for a staircase, hobbyist and personal. The early Slackware and SLS distros from the time also didn't include web server or tools to run a business. The first people on the subsequent use case steps didn't get there with clean off-the-shelf solutions. They played the scout role, clearing the road for the army to roll in, which is why the web server book in 1995 now includes Linux. Another benefactor of the eternal September is attributed to Linus's law. Given it enough eyeballs, all bugs are shallow. Let's look at the various eyeballs. In the first term slide, I said Linux was mostly built by college kids, and here's some evidence. After the first posting in October, Linux got some help from a local friend, but by November he had contributions from Hong Kong, MIT, and University of Utah. In December, contributions came from Calgary and Berkeley, then Colorado and Maryland students contributed in January. So far, everyone is under 25, and as I said before, there becomes an increasingly pressing need for solutions like Linux to solve new problems. And those needs more or less persist to this day. Apple is vertical, Microsoft is entitled, and Linux continues to climb stairs that have yet to be drawn. Here's a quote by Torvalds. I think the timing was good. Even just a year earlier, I don't think it could have been done. And a year later, somebody else would have done something similar. These 2 bottom charts show how Linux now dominates supercomputer and web server space. How's everyone doing? I hope you're still awake. Yes, that is typed on this sheet as well. I know this is so long, so let's have some fun. If there was a storefront named open source, what would be displayed on the windows? In fact, let's do some interactive theater. We are a group of people in 1985 trying to bring free software to the masses. Our marketing director just told us about the marketing mix with 4 Ps: product, price, place, and promotion. In order to have a figurehead for the free software movement, we need to find a piece of free software that qualifies these conditions. It should be easy to try, acquire, and understand. It should have a low price of time, money, and expertise. I appreciate the suggestions so far. These are all excellent examples of free software. I especially like the elevator pitch for Emacs org mode. Before we settle on a project, I'm wondering if we've left anything out. Any suggestions from the audience? Oh yes, you sir, the man I've known for over a decade. Oh, that's a great idea. Maybe Linux can be the window dressing of the free software movement. Or how about this? I have a better idea. Let's make an alt copyright pipeline. We have low effort things for curious PC users to try. Then we tell them the beliefs of our community and get them to up their commitments. As they do, they'll become more familiar with projects that take effort and expertise, get more involved, and be an advocate for them. Over time, some of these people will aid us, if we're lucky, in reporting bugs, determining needs, and implementing desires to move our aspirational project forward to make it more tangible. In order to do this, we must be a welcoming community, by necessity, but also because we brought in the right people. So, that's how it happened. Oh wait, how do we do it again? Okay, the final boss. Jeffrey Moore posed... I know, right? Jeffrey Moore proposed this graph in his work Crossing the Chasm in 1991. I need to do that. It proposes that as commercial products mature, users with different behaviors and expectations come around. There's two holes in this graph. The first group is people who are aspirational and have a high tolerance for impracticality. They're willing to go the extra mile to make something work. There's a group that's enthusiastic about the possibilities but want a lower effort, time, and expertise costs. In the graph on the right with electric car adoption in Norway, you can see that small slump, that's the first circle. The next group is the difficult one. They are looking for a working product and don't want to be hassled with inconvenience. That's the yellow circle in the graph. Many products don't make it there. The last two are really the bandwagon and the holdouts. Anyway, let's look at the crossing the open source chasm. The first group here are the passionate hackers trying to claw at the aspirational curve and bring it down to the bugs and needs. If they can keep their passions going long enough and make sufficient progress, then perhaps the music makers will come around and help recruit more passionate people to enlarge that base. That's the first pipeline. If the engine between the passion and the enthusiast can be maintained in order to get the problem-solution integration wheel, the project can get pulled out of the Turing carpet, and if the software capabilities divided by the effort demanded yields enough of a utility ratio, then the pragmatist will become interested in a chasms crossed. But it's important to keep the pipeline well lubricated because you'll be facing new challenges and use cases, and you'll need a few of those new users to slide along the responsibility graph in order to grow the coalition as the law of division takes hold. Back when we talked about Platonic ideals being permeable, bizarre superstructures occupied by various executions, I said the clarity of the present stands on both the triumph and the wreckage of the past. Sometimes for a city to become great, it must first be destroyed so the new generation can seize the dream and try to execute it better. Failures unbind us from commitments and give us permission to kill our darlings and do a page one rewrite by naturally creating the space for us to try again, but only if we retain the liberties to do so. Strong IP enforcement on strong vision diminishes their chance of success. You must let go of that which you love the most. You may get the vision right, or the execution, or the timing, or the team right, but probably not all at once. Facebook, iPhone, Google, Amazon, they're all iterative executions of larger ideas owned by nobody. If you're working on a thing and have a dream and it's just you're definitely on the very left. You could argue that for certain use cases, Linux took over 20 years to cross the big chasm, and for some things, desktop publishing, digital audio workstation, photo editing, or social media, free software chasm is still not crossed. There needs to be a certain kind of affection for the people, their needs, their desires, their aspirations, for these to eventually succeed. For, say, the GIMP to overtake Photoshop. The commitment to others, lowering the responsibility charge is key, because that's how you get the new recruits. So, whatever you're working on, it will take years to manifest differently than what you thought. You have to not have codependencies with it. That will foster resentment, anxiety, and low self-esteem. Really, you'll probably become susceptible to the great man theory. If something is dying, maybe that's the fire you need to rebuild it. Listen to the needs and desires of the idea. Do one thing and do it well. Work together, handle text streams because that's a universal interface. This is actually the Unix philosophy of Peter Sallis, but I'm serious about it. Good software advice is also good people advice when building software. Let's go to Tracy Goddard, Soul of a New Machine, 1981. Looking into the VAX, West had imagined he saw a diagram of DEC's corporate organization. He felt that VAX was too complicated. He did not like, for instance, the system by which various pieces of the machine communicated with each other. There was too much protocol involved. He decided that the VAX embodied the flaw in DEC's corporate organization. The machine expressed that phenomenally successful company's cautious bureaucratic style. Churchill said, "We shape the buildings and thereafter they shape us." However, our buildings are different because a programmer, like the poet, works only slightly removed from pure thought stuff. He builds his castles in the air, front air, creating by exertion of the imagination, or so says Fred Brooks. Regardless, wrecking balls for code are cheaper than those for concrete, so don't be afraid to use them. Here's another Unix philosophy. This time, think about it in terms of people. Make it easy to write, test, and run organizational efforts. Interactive use with humans instead of batch processing. Make do with smaller teams. You will need all the engines I talked about to get over the chasms and move the projects forward. Organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. Melvin Conway, Datamation, April 1967. We study yesterday to create a better tomorrow. Futures are ours to make. Probably. What was that? Also under 40 minutes. This is great. I can slow down even more. Scout is a CI/CD tool, which I don't really do a lot of, but I don't know. That's what this one is. I think that was casual. I did do a couple rewrites. I think that, what I'm trying to do is I'm trying to avoid ways that I might stumble over words. So if I have like two B words that are adjacent to each other, I'll try to avoid that. I'm also, very conscious of consonants, and so if I can be like, oh, that's a six consonant way of saying things, and let's see if I can find a 4-3-1, or remove a word here or there, or try to take out something that's like doesn't belong. I'm trying to make this as tight as possible because there's a lot of stuff here. I just pulled off my headphones, and I dropped that USB thing down here when I better pick it up before I destroy it with my chair. Anyway, yeah, I'm okay with this. This is not bad. I was scared. I was scared it was just going to be too long. I'm still not relaxed enough for the jokes to work, so that's just going to come with practice and confidence. I know that one of the things I want to do is eventually, when I get to scale, I think it opens Wednesday. Let me see. It's a good question. Scale Linux. Let's see. In fact, you can see my screen. I don't care. Ooh, look, a bunch of women are on here. That's nice. Oh, you can't even see the woman. Look, Kyle Rankin. Who are these people? Famous people. I'm not famous. Let's do exhibit schedule. That's it. So, Thursday. There it is. So you can't see this. So yeah, so I start Saturday and Thursday. I'd love to get there. And Ballroom B is open on Thursday. Look at that. It starts at 10 and it's over at 5. Ooh. So I can then practice at that time. Unless they try to kick me out. But I could try 5:30 and just practice it for an hour or two. And what is this? UbuCon, LLMs from zero to hero. I should probably look at these things, see if there's anything here that I like. I've been so preoccupied with mine, I haven't even seen anybody else's. And it's going to be difficult because I'm going to be in a situation like, in fact, let me just move this thing up. I'll be all judgy, like in the back of my head, even though I'm trying to enjoy it, but yeah, I did better than that. Oh, look, that person didn't practice enough. Ooh. I see what the problem is. I'm going to be like some kind of mean girl, just in my head. Like, even if I don't try to be, it's just kind of like my natural proclivities, if you will. Like, Let's see. I should probably find out what's going on here. They used to be really fucking boring. It was like all CI/CD stuff. It was stuff like configuring some obscure Kubernetes thing, followed by some other cloud thing, followed by some bizarre, dashboard thing. It was so fucking boring, and that's why my talks, I think, never got approved, because I was doing like fun and interesting stuff, and I wasn't just like, using Docker with Prometheus. Like, fuck that. Like, seriously, just like read the documentation. I'm not gonna like sit through what the fuck, God damn. Like, I don't know why anybody cares about that. Just that's like, how can I say this? That's like, going over like the different kinds of nails and hammers, as opposed to like telling you how to do the woodworking, right? Telling you how to actually build something. Like, that's the important part, right? Things that I'm trying. Oh, there's that arrogance again. Yeah, I should try to find out what else is going on here. Let's see, Ballroom B. So on Friday, it's open for even longer. Look at all that time. Oh, you can't see anything. This is so small. And look at all that extra time. What the fuck is upscale? I should click around on these things to figure out what's going on. I want to log in. Since I'm going to be a speaker and I'm a volunteer and everything like that, I should know what the fuck's going on. Shift left. Oh, he doesn't actually mean politically left. Well, who cares? Oh, hold on. Is that shift left the website? because there's a shift left out there, which is like an archival site. It's shiftleft.com. Oh, come on. Oh, come on. Shift left Usenet archive. Yeah, there it is. There, shift left. See? You have all of these. Some really nice archives on there. Can implementing shift left? No. It's got nothing to do with that one. So, yeah, I know where all the archives are. Like hidden on some server somewhere. Yeah, kind of I don't know. Anyway, I should go over this stuff. Oh, FreeBSD. Oh, nice. All right. Let's just end this now. I will do this again tomorrow morning. And hopefully it'll be better.